Hello my dear students, I warmly welcome you to CR Digital Classes. So in this lecture, we are going to discussing about the same previous concept only, the equation of tangent plane. Under this concept, so we are going to discussing one more problem. So very important problem, especially for long answers. So in previous lecture also we discussed one problem based on this concept only, tangent plane. Now one more question. Show that the plane 2x minus 2y plus z plus 12 is equal to 0 touches the sphere and find the point of contact. Okay, in the previous problem, in this problem the difference is in previous problem they were asking about find the sphere equation. In this problem they are asking about find the point of contact whenever the given plane touches the given sphere. No need to find the sphere equation, just we need to find the point of contact equation, that is x, y, z values of the given plane equation. Okay, so therefore point of contact is nothing but whenever that plane touches the sphere. Okay, so at that point that plane value will become 0. So now we have to find x, y, z values of the given plane equation. That is the concept of this problem. So no need to find the sphere equation, already sphere equation is there. So now to find the point of contact, so given equation of the sphere is x square plus y square plus z square minus 2x minus 4y plus 2z minus 3 equal to 0. Take it as equation number 1. Now, and equation of the plane is 2x minus 2y plus z plus 12 is equal to 0. Take it as equation number 2. Remember carefully, equation number 2 is the game changer for this problem. Okay, compare equation number 1 with general sphere equation. Okay, equation number 1 is the given sphere equation. Compare with the general form. Okay, what is the general form? X square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. After comparing the corresponding coefficients, so 2u is equal to minus 2. Okay, x coefficients, y coefficient 2v is equal to minus 4, z coefficient 2w is equal to 2, and constant d is equal to 3. 2 get cancelled, u is equal to minus 1, 2 1 the 2 2s are, so v is equal to minus 2, 2 cancel, w is equal to 1. Okay, so now after comparing the given equation with general form, okay, now the next step is finding the sphere of the center of the sphere. Why? Because the given plane touches the sphere. Touches the sphere means we have to find the condition from the center of the sphere, that perpendicular distance we have to find to that plane. If that distance is equal to radius of the sphere, then only we can find the point of the contact. Okay, so center of the sphere, you know very well the formula, minus u minus v minus w. Substitute the corresponding values, minus of minus 1 comma minus of minus 2 comma minus 1. So therefore center is equal to 1 2 minus 1. Similarly we need also radius, so therefore find the radius of the sphere also. Small r is equal to under root of u square v square plus w square minus d, that is the formula. So therefore small r is equal to u value minus 1, so therefore minus 1 whole square plus v value minus 2 whole square plus w 1, so 1 square minus of minus 3, so therefore small r is equal to under root of 1 plus 4 plus 1 plus 3, so therefore 7 plus 3, 7 plus 2, 9, root 9 is equal to 3 units. Radius of the given sphere is 3 units. After finding the radius, so now perpendicular distance P is equal to, we can write from the center of the sphere to the plane 2x minus 2y plus z plus 12 equal to 0 is, this is the general formula for the perpendicular distance. You know very well, in two dimensional when you take xy, okay, when you take only x axis y axis, we can write distance between perpendicular distance ax1 plus by1 plus c by under root of a square plus b square. But in the sphere is always three dimensional, therefore we'll get three coordinate axes. So for the three coordinate axis, this is the formula. Small p is equal to mod ax1 plus by1 plus cz1 plus d by under root of a square plus b square plus c square. Substitute the corresponding values. Here x1 comma y1, x1 comma y1 comma z1 is equal to the center of the sphere. What is the center of the sphere? 1 comma 2 comma minus 1. That is the center of the sphere in place of x1 y1 z1. And what are the a b c values? A comma b comma c values we can obtain from the equation number 2 given plane. You know, a is equal to 2, b is equal to minus 2 and c is equal to 1. Okay, so therefore p is equal to, substitute the corresponding values, and if you simplify, so 2 into 1 minus 2 into 2 plus minus 1 plus 12 by under root of a square plus b square plus c square, 2 square plus minus 2 whole square plus 1 square. So therefore p is equal to 2 minus 4 minus 1 plus 2 plus 12 by root 4 plus 4 plus 1, that is root 9. So the value is mod 9 by root 9. Mod 9 amma, this is mod 9 by root 9. So therefore 9 by root 9 value 3, 3 1s are 3 3s are. So therefore we got the perpendicular distance value small p is equal to 3. So 3 units. Hence radius is equal to small r is equal to perpendicular distance. Then only the plane touches the sphere. Why? Because previously what is the radius of the sphere amma? Radius of the sphere also r is equal to 3 units. And perpendicular distance also we got p is equal to 3 units. Both are same. Okay, so if both values are same, then we can say that the given plane touches the sphere at one point. Okay, now that one point we are going to find, that point is called point of contact. Now to find the point of contact, the direction ratios of the normal to the plane. Okay, so this is the given plane. From this plane, if you compare that plane with ax plus by plus cz plus d is equal to 0, then what are the ABC values? X, Y, Z coefficients, x, A, B, C values we can write. These are the direction ratios. Then the equation of the line passing through 1, 2, minus 1. What is 1, 2, minus 1? Center of the sphere. Okay. Equation of the line passing through the center of the sphere and perpendicular to the plane is given as. Okay. So that means indirectly they are asking equation of the line. This is the center of the sphere. Equation of the line passing through center of the sphere, and this line equation they are asking, that is x minus x1. This line is, for example, if you take this point capital P, CP line equation only this one. Okay, x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Okay, so where you know very well x, x1, y1, z1 are the center of the sphere, and ABC values small a, small b, small c values are the direction ratios of the given plane. Substitute the corresponding values. X minus 1 by 2 equal to y minus 2 by minus 2, z minus of minus 1 by 1. So this total value we are taking as a lambda, where lambda is any constant value. Okay, so therefore now x minus 1 by 2 is equal to lambda, y minus 2 by minus 2 is equal to lambda. Just we have to equate each and every value. So equate each and every value with lambda, then we'll get z plus 1 by 1 is equal to lambda. So therefore now send this 2 value to RHS. X minus 1 is equal to 2 lambda and y minus 2 is equal to minus 2 lambda and z plus 1 is equal to lambda. X is equal to, if you send this minus 1 value, x is equal to 2 lambda plus 1 comma y is equal to 2 minus 2 lambda and z is equal to lambda minus 1. So the main intention is, if you know the lambda value, then we can get the x, y, z values. Okay, so now to know the lambda value, so parametric equations of the line CP. Okay, whatever that line perpendicular distance is there, that CP, parametric equations are in this format. X is equal to 1 plus 2 lambda, y is equal to 2 minus 2 lambda and z is equal to lambda minus 1. Previous values only we are calling them as parametric equations. Take it as equation number 3. Now substitute these parametric x, y, z values of the equation number 2. Substitute in equation number 2 only. So therefore 2 into 1 plus 2 lambda. Wherever you have, what is the equation number 2? 2x minus 2y plus z plus 12 is equal to 0. Wherever you have x, y, z, substitute corresponding values in terms of lambdas, okay, in equation number 2. So 2 into 1 plus 2 lambda minus 2 into 2 minus 2 lambda plus lambda minus 1 plus 12 is equal to 0. Simplify, multiply with 2 2 into 1 2 plus 2 into 2 4 lambda minus 2 into 2 minus 4 minus into minus plus 2 to the 4 lambda, okay, plus lambda minus 1 plus 12 is equal to 0. 4 lambda, 4 lambda, lambda, okay, 4 plus 4 8 plus 1 9 lambda, and minus 4 minus 1 minus 5, and 2 plus 12 14, 14 minus 5 9. So take 9 common, so lambda plus 1 is equal to 0. So send lambda 9 value to RHS, 0 by 9 0, lambda plus 1 is equal to 0. So since 9 not is equal to 0, so therefore definitely lambda is equal to minus 1. Substitute this lambda is equal to minus 1 in equation number 1. So from the parametric equations we can get x is equal to 1 plus 2 into lambda, actually 1 plus 2 into minus 1, therefore 1 minus 2, that value gives you x is equal to minus 1. Next y value 2 minus 2 lambda, actually, so therefore 2 minus 2 into minus 1, so therefore minus into minus plus, so therefore 2 plus 2 is nothing but 4 only. Next z is equal to minus lambda minus 1 minus 1 minus 1, z is equal to minus 2. So therefore finally we can write from the parametric equations x, y, z is equal to minus 1, 4, minus 2. This is the point of the contact, okay, of the given sphere and the plane 2x minus 2y plus z plus 12 is equal to 0. Even if you substitute this value in the given plane, you will get LHS is equal to RHS. That means just to do the verification process, cross checking once. So just to substitute the values, x value 1, x value minus 1 minus 2 into y value 4 plus z value entama minus 2 plus 12 is equal to 0. Okay, minus 2 minus 8 minus 2 plus 12 equal to 0. Minus 2 minus 8 minus 10 minus 10 minus 12 minus 12 minus 12 plus 12 is equal to 0. 0 is equal to 0. We got the verification is also. Okay, this total process no need to write in the examination, but for your confirmation you have to cross check after getting the solution whether the values are correct or not. Okay, so this is the process to find the point of contact when you get the only plane equation and the sphere equation. Okay, just remember, whenever the perpendicular distance is equal to radius of the sphere from the center of the sphere, then only the given plane is called a tangent plane of the sphere. Okay, that is a very most important topic. So I hope you understood this problem very well. So in this next lecture we are coming with another concept. Make a perfect practice, prepare well. Until bye, thank you.